Thank you, Phoebe. So from this point onwards, all the presentations will be recorded this morning and this afternoon. You can go on the NIAB website, www.niab.com, to view those recordings, and we will contact you to let you know when they are available. So for those people who have joined today and would like to receive some basis points, we have applied for basis points, both for the professional register and there's a new category as well, I understand, on environment, which I'll share with you shortly. If you want to register points for today, there are 4 available, all for those different categories, 1 for crop protection, 1 for environment, 1 for application practice, and 1 for integrated pest management. There is a QR code there for you to use. So for those that are proficient with these things, if you want to zap that code with your phone, you can then register your full name, your basis account number, and your postcode to claim those points from basis. Or if you're not able to do that, there is the possibility of sending us your details in the chat facility and we can add them for you. So that's for the basis professional register. But we also have, I understand now, there's a new category within basis for environment, and that is the QR code to use for the environment. Similar number of points and categories available for that, and the basis reference number is there at the top. So if you want to zap that QR code now, again, you can do so. Again, adding in your full name, basis account number, and postcode. And finally, for those who are interested in Aroso points, there is the opportunity again to register for points for that. There is your QR code. Again, if you're not able to use that, you can send us your details, full name, Aroso account number, and postcode in the chat facility. So very quickly, what have we got lined up for you in session 1? We have an eclectic mix of different talks here, but we're going to learn a little bit about growing Kent and Medway and British apples and pears, and the potential of some new work that might come the industry's way through growing Kent and Medway. Richard Colgan will be talking to us about his latest storage work that he's been doing. And then we'll have 2 talks on rootstocks. We'll have a little bit of information about M200, a new rootstock that was bred by NIAB at East Malling, and also from Amanda Karlstrom on a process to speed up apple breeding. And then we'll have a very short presentation about a piece of apple work that Laurent Giguere is undertaking. So enough of that, and I'd like to invite our first speaker, Robert Saville. Robert is a colleague of mine at the Growing Kent Medway team at NIAB, and Robert's going to share some information with us about what Growing Kent Medway is doing to support sustainability and innovation in the tree fruit sector. So Robert, I think we've got your presentation there, which is great news.
Very good. Can you hear me, Scott?
I can hear you absolutely fine. So I'm going to just stop my video and mute myself. So the platform is yours, Robert.
Thank you very much, Scott. So I haven't got much time for myself and Rachel to cover what we want to cover today. And normally I'd go into a few slides about explaining what Growing Kent and Medway is. But I'll just briefly talk about that on to this slide. So Growing Kent and Medway is funded through UKRI's Strength in Places Fund. It's led by NIAB and involves the 3 main universities based in the Kent and Medway regions. That's University of Kent, University of Greenwich, and Canterbury Christchurch University, as well as Locating Kent, which is the inward investment agency for the region, and a number of business stakeholders that are based and operate in our region. We support innovation in the horticulture and plant-based food and drink sectors, so building on a big strength of our region in the southeast. We do this through a number of initiatives with innovation, supporting innovation and enterprise growth. And I'm going to talk to you today about one of these initiatives and how it is supporting sustainability and innovation in the tree fruit sector. So last year we ran the Business Sustainability Challenge. And the Business Sustainability Challenge is a competition where we invite our target sectors, so that's horticulture, and plant-based food and drink companies to propose innovative ideas, processes, and technologies which support sustainable production, products, and packaging in the fresh produce, food, and drink supply chain. This round one of this competition opened last year, and we supported the development of a number of projects which focused on two main themes. So sustainably transforming operations within the fresh produce, food and drink supply chain, and helping to create viable circular economies in our region. And we set a number of core themes or scope areas that we wanted the businesses to incorporate into their ideas and projects that they proposed. And we have a short 2-minute video which will illustrate some of these examples, hypothetical examples. So the industry responded in our round one of the Business Sustainability Challenge, and they put forward seven different proposals that we ultimately funded, and they took a share of £260,000 in grant funding to conduct their projects. And I'm just going to go through a few of these now, just to give you a taste of what we're funding. They're currently underway. So we funded Nim's Crisps based in Sittingbourne. So they make fruit-based, vegetable-based crisps. And they propose to use surplus fruit and veg, fresh fruit and veg, to create new innovative products that will help consumers reduce their own food waste. Grow Up Farm, which is a vertical farm based in Sandwich, teamed up with a spin-out from University of Birmingham, who have developed a next generation water purification system. This will enable Grow Up to reuse and recover both rainwater and water that's run off from their leaf production, and thus using less resource. Canterbury Brewers and Distillers based in Canterbury have got a project looking at how they can close the loop on some of their waste resources. So they're using waste grain, water, carbon dioxide and energy from their distillation process to grow specialty mushrooms, which in themselves can be used as ingredients for their restaurant and distilling businesses. Tensai is a company based in Canterbury, specializing in using agri-waste and finding new uses for it. So they're calling this a second harvest. And this particular project is focusing on creating polymer compounds to replace plastic products and incorporating agri-waste substrates. And finally, the project, finally from the projects that I'm going to highlight is Hume's ACH Farming is leading a project to improve the energy efficiency of apple cold stores without compromising the quality of fruit. And given the audience today, we've got Richard Colgan, who's going to touch upon this project. He was instrumental in bringing this consortium together and is leading on the technical side of this project. And in his talk, which is up next, he'll cover some of the technical approach and outcomes from this project. And we have a pre-recording from Rachel McGauley of British Apples and Pears Ltd. They are one of the consortium members on this project. So I'm going to hand over to a pre-recording of Rachel now and run through 7 or so slides.
Hello, for those of you that don't know me, my name is Rachel McGauley. I'm the R&D Programme Manager for British Apples and Pears Ltd. And prior to this, I was the AHDB Fruit Research Manager. So following the demise of AHDB Horticulture, the continued need for research and development for the apple and pear sector was identified by Ali Kappa, who I'm sure you all know is the Executive Chair for British Apples and Pears. So Ali, with the support of the British Apples and Pears Board, thought of a way to make this research continue. So since last year, apple and pear growers have paid a voluntary subscription to fund research, also for EMUs and emergency authorisations. So as part of this, I manage the British Apples and Pears Technical Committee, who are a fabulous group of 14 volunteers from the apple and pear sector. So these are agronomists and advisors, people from organic businesses, conventional businesses, independent growers, and growers who are part of marketing desks. This group is chaired by the fabulous Rob Saunders, whose picture is just below. And these people help me identify the priority areas for research, but also for the emergency authorisations and EMUs for the industry. So some of these priorities we can fund directly from the voluntary subscription that the growers are paying. But as with everything, funds are always limited. So I also look for opportunities for external funding. So this is where the Sustainable Business Challenge has come in, because that's helped with some of our other priorities. Given rising energy costs and also the pressure for the industry to work towards net zero emissions, the Technical Committee has identified reducing energy use for storage as a priority area for research. This idea fitted well with the Business Sustainability Challenge, which obviously it's in the title, requires projects which relate to sustainability, which this idea obviously does. So I approached Richard Colgan from the Produce Quality Centre, who I knew from my previous role at AHDB, and we together talked to Saville from Kent Medway. And then together we went about building a consortium of interested organisations to apply for some funding to tackle this problem. So with the help of Saville and Richard Colgan's contacts, we built a consortium of partners to apply for this funding. So it's a consortium between AC Human Sums, who are the project lead, Debbie Rees and Richard Colgan at NRI in the Produce Quality Centre, STEMI Energy, Grid Duct, Avalon Fresh, JD Cooling, and then British Apples and Pears. We were successful with the funding application, and the project began in September, so just in time for harvest. And then the project will end in March, so giving us a good few months of storage to get some results. So the role of British Apples and Pears in this project is to conduct a grower survey, which I did at our recent Research and Development Day. So I'll give you the results for that now. Because this was a relatively short project, we wanted to gauge the interest of growers in doing any follow-on work as part of a bigger project. So I know that this is a priority area for the technical committee, but I just wanted to make sure the interest of the wider industry. And since we had an opportunity with the technical day a couple of weeks ago, I thought I'd ask the growers there. So I asked them, first of all, if they're interested in understanding more about their energy use. And the results were overwhelmingly in favour. So of the 27 people that responded, 96% of them said yes. So then I asked if they had systems in place to help monitor the energy use of their stores, because this is going to affect the kind of project we can do. We need to know whether we have to put in monitoring systems or if there are some already in place. The result here was quite mixed. So 61% of growers said yes, but obviously 39% said no. So we need to bear that in mind when building any future research. For a lot of stores, we're going to have to put something in. And then for the growers that use these, that have these systems, I wanted to know if they actually use them or if there is something in the way. So 61% of them said that yes, they did use these systems. But 6% said no, they don't have time. 6% said they don't know how. And then there was a further 28% that said no for another reason. So that's quite interesting and perhaps needs further investigation, because these systems can potentially save growers money. So it'd be interesting to know why they're not using them. And then as the final multiple choice question, I asked if they'd be interested in a more nuanced system. So one of the partners in our project is STEMI Energy, and they have systems where they can turn down stores or turn them off. And so that's one potential idea. And 100% of the people that responded said yes, they would be interested in this. So then as a final question, I did a word cloud, which you'll see on the next slide.
Sorry, Rachel.
So the results from the grower survey were positive. It shows that not just the technical committee, but wider growers are interested in doing some more research on energy use in stores and saving money and reducing carbon footprint, which is great. So as this has been quite a short project, but it's been really helpful, but we hope to take the results from this and apply for a bigger project, hopefully over multiple seasons, so we can understand energy use better and find ways of reducing the energy use. I'd just like to take this opportunity to say thank you to all the partners in this study, and particularly Richard Colgan for doing a lot of the work in building this project. Also to Robert Saville, who was really helpful at the start of the project, and he's continued to be helpful throughout, giving advice and helping us to build our consortium. So it's been a really good experience for us all. So as I said at the start, if you want to get in touch with me, please feel free to use the email address there. That's research@britishapplesandpears.co.uk. Thank you. Bye.
Thank you, Rachel. So if what myself and Rachel have been saying and what Richard will go on to say about the Business Sustainability Challenge has whetted your appetite to inquire and get involved, you'll be pleased to know we've got round 2, which is launching next week on the 1st of March 2024. And the applications are open for 2 months, closing on the 30th of April. Just a bit of top line information about the scheme. We require 50% match funding, which is reimbursed. So the grant element of that is reimbursed at the end of the project. Funding available is between £10,000 and £50,000. So that means that based on 50% match, total project costs are looking at 20 to 100k plus. We're looking to fund short-term, high-impact, innovative projects. These aren't capital grants, so they can't go to buy capital as such, but the capital usage or usage of capital items is covered as an eligible cost, and we can talk about that if you want to understand a bit more about that. Collaborative projects are encouraged, and the Apple Store Energy one is a great example of that, but they aren't compulsory or mandatory, so you can go solo. Lead applicant must be a Kent and Medway based small or medium-sized enterprise, and at least 75% of your project activity should take place in the region of Kent and Medway. But with the collaborative projects, you can bring in partners from outside of this region, and as long as these conditions are met. So those on the call who are interested need only sort of, but aren't based in this region, need only sort of find a collaborating partner who could potentially lead, who is based in this region. That's very top line, but if you'd like to find out more information, we're holding an online briefing on the 1st of March at 11 o'clock. So that's next Friday. I've got a QR code that's been generated, which will take you to the booking page to sign up for this briefing. And my colleague Lauren will hopefully share it in the chat function. So you can click through it there as well if you want. We've also got a lot of information on our web page for this competition, and that's it's via this bit.ly link, which will also be shared in the chat. So my final slide, if you do have an idea that you think might be suitable for funding through this scheme, then we'd love to talk to you, and I can be your first point of call. So there's my email address. You can also find more information about this scheme and all the other initiatives that Growing Kent and Medway are delivering through our website, growingkentandmedway.com. And to keep up to date with all of the developments from our programme, including our grant opportunities, I recommend you become a member of Growing Kent and Medway Network. It's free, and it just means you're signed up for all our newsletters to come straight into your mailbox, monthly newsletters. And you can do that on our website by clicking the pink tile in the top right-hand corner. Also, my colleague Lauren will share a link to how to become a member in the chat. Okay, back to you, Scott.
Thank you, Robert. Robert, can you just switch your camera on? I didn't want to interrupt your flow, but just to prove that Robert does exist and this wasn't a recording. Thank you very much, Robert. Just to reiterate what Robert said, and all information in the chat facility that our colleague Lauren Colagiovanni has been adding. There's a phenomenal amount of good work that goes on through Growing Kent and Medway. We're very fortunate to have both the funding and the structure there to help and support the food, drink and horticulture industry. Please, please, please do look at the website. Lauren and our colleagues work tirelessly to keep that up to date. And there's always new information coming on there about the latest projects that are coming up, the latest funds that are available. So please do use it. Robert, I don't think we have any other specific questions for you, but I know you're going to stay for the rest of the session. So please hang around. If you do think of any other questions you've got for Robert, do post them in the chat facility. But for now, Robert, thanks for your time. And it flows nicely into our next speaker, who is Richard Colgan, who's known to most people in the industry. Richard has spent most of his life researching post-harvest technology, not just in apples and fruit, but also in other fresh produce. And Richard is going to tell us a little bit about one of the Growing Kent and Medway initiatives, which was alluded to earlier on apple storage. And he's also going to tell us a little bit about a new sprayable formulation of Smart Fresh by AgroFresh. So, Richard, good morning to you.
Good morning and welcome. Thank you for inviting me to give this talk. So I'm going to, as Rob and Rachel alluded to, I'm going to talk about the business innovation about something about that we were speaking about previously. This is a a talk. This is a project that was developed through a consortium, as Rachel mentioned. These are the partners. I don't want to go back again, but certainly people like Tom Hume and Nigel Jenner were integral in helping to set this up. We have two energy product companies called GridDuct and STEMI, and BAPL are also very welcome partners. So what we're trying to do in this project is to understand something about in more granular detail about how energies are used across the storage complex. And I know many growers are using various tools already, but we're wondering whether this can actually complement this set of existing tools or add to what they already have in terms of providing some filling in the gaps. So what we offer in this project is looking at two different sort of technologies. One is called grid duct sensors, which we apply to a number of different pieces of equipment in the store. So the chiller pack for one, the CO2 scrubber, nitrogen generator, and the fans in the store. So we get quite a detailed understanding of the energy use, hourly energy use of that equipment. And then that's uploaded to a dashboard on the Grid Duct website that allows you to sort of interrogate that information in quite a nice, easy to use fashion. And then the other company, which was mentioned, is called STEMI Energy, and they're trying to use a really sort of detailed understanding of the energy use of stores on a minute-by-minute basis, and then trying to link that in with the demand requirement or the demands on the grid. So if there are chances to dial down some energy use at any one time, then there might be a saving which in energy consumption, which can then be monetarized, so that growers can have some sort of payback for doing some options. But clearly what we don't want to do is compromise fruit quality. And so this is really just starting to understand what are the sort of bandwidth to operate in to allow this equipment to work effectively. So we're looking at a number of stores. So we have some stores both in the produce quality center, but also commercial stores where we are just monitoring energy use at the moment. So we have some stores, Ghana stores, running at sort of standard temperatures of 0.5 to 1 or 1.5 to 2. We also have some DCA stores operating too. And we're just looking at the energy use across those stores currently. And so these have been attached. So we've been attaching the clamps to various bits of kit. For example, in the bottom hand corner, where you see one of these energy clamps that fits onto an electrical tail. And then this gives a nice readout. This is uploaded to the internet. And then you get a readout, an hourly readout of, in this case, total energy use, but it can be for individual bits of kit. This next slide shows you the chiller pack, and then the fans operating in different stores, and the scrubber. So it gives you an idea of where your energy is being used, and whether there's any scope to sort of maybe shift some of that to periods of less peak use, where maybe we get a cheaper tariff. Again, this is just an example of a scrubber. We were looking at how much energy is that using that day, and how much is coming on and off. You need to make sure the scrubber is doing its job, doing the CO2 at the right concentration. But the question is, also the question about is actually is the actual equipment installed energy efficient? Does it need servicing? Do we need to replace it? So some of the savings can be achieved by just understanding how much energy each bit of kit is using, and then benchmarking that against industry standards. At this stage, we want to understand, what, if any, the impact is on fruit quality. So we're looking at, in this project, we put the temperature probes into fruit at different points in the store, and they were then downloading the information onto a website, and we were able to understand the temperature profiles of the individual fruit present. Equally, we've been doing some work in our stores in the produce quality center, where with STEMI have been looking at both the energy consumption of our chiller pack, but also using thermistors, the Dixel output of our thermistors on stores to look at temperature differences when they start to change the temperature of the actual air temperature. And we back that up with looking at fruit temperatures inside the store. And so the idea about this is that if you can shift energy use even slightly for an hour or so throughout the day, then there is potential to get some savings in terms of the payback from the grid. As an example, of some of the work we're putting into some gala, where we are taking the temperature of the fruit for every sort of 5 minutes, measuring that, and then changing the still temperature from say 0.5 degree to up to 2 degrees, and seeing how that temperature shifts, both external and internal temperature. That's that project. I'm sure it's quite a quick one, but we had some introductions to that before. The last 10 minutes, I'd like to talk to you about some work on another project, which is really funded through AgroFresh and Lancia. This is really a demonstration of work they've already been doing for some number of years, looking at the managing apple maturity using a sprayable version of 1-MCP. I'm sure many growers are already familiar with this work. But we obviously know that, with the variability in apple maturity in orchards, then it often requires growers to go back and pick fruit for a second or third time to make sure the colour is there. But that later picked fruit will have inherently shorter storage life. Therefore, things we can do to reduce that change in maturity, but still allow the fruit to colour, will have great advantage to the growers. And also, it's quite a big energy, labour and transport costs associated with going back into orchards to repeat pick. So this version of a sprayable formulation of MCP, I mean, in the US, it's been registered as harvester, but we haven't got registration in the EU or UK yet, so we have to refer to it as a sprayable formulation of MCP. Along with NIAB and ourselves at NRI, we're undertaking some demonstration trials on Gala for 2022 and 23, and with Jazz just last year. NIAB have been doing the spray applications. This is an example of just a trial plot for Gala at NIAB site this morning, where we have been using a modified triprop sprayer with Adrian has been collaborating with Seymour's to modify the actual application with different nozzle rates. So ideally, this is applied 14 days before you want to harvest the fruit. And in this case, we sprayed we sprayed the product on the 6th of March with anticipation that 6th of September, which we want to then harvest till late September. An example of the sprayer, and Adrian's online if you want to, in the chat, you can talk about how the sprayer works and application of the sprayer. An example of the work on Gala. So we sprayed on the 6th of September, and then we followed the starch pattern that we qualitative pick fruit and followed the maturity, which you can see with a treated product in terms of starch clearance. We still had a fair on 21st of September, we still had 85% starch content, compared to the untreated, which was 15% less in the untreated. So you can see a benefit of applying this product to maintain the starch content. And if you look at that in terms of just the variability, which I think to me has been a really interesting point, is how much the treated product fruit is less variable. But in bars, the longer the bars here, it's showing you more variable starch across the sample you harvested. When you have shorter bars, as brown, these are the treated ones. There's a much more homogeneous sample, and the fruits are less more starch in them. So I think that's quite important that we're actually reducing the variability across the orchard with this product. And then we picked fruit for a larger scale assessment. Both the first pick for untreated was where we anticipated the commercial pick to be for untreated fruit around the 15th of September, and the fruit was still had 56% starch in it, and fairly good red. And a number of the fruit had 7% of the fruit had over 50% red colour. But we then waited another 10 days to pick the treated product, and again we still maintained a good sort of starch content in the fruit, and we had raised the colour portion of fruit with red colour. If you look at that with the untreated picked at the same time, you can see starch has cleared by about 15%, but the red colour is still there. So you can see that there's been advantages of having this treatment in terms of fruit maturity. Now we also did work this year on some Jazz. This is at Broadwater Farm. Adrian was also applying 1-MCP. And again, we did some maturity picks from mid-September all the way through. We treated the orchard on the 26th of September, and then carried out the maturity picks. The orange bars here are the fruit that are treated, and the green are untreated. And what one can see is that the green untreated, the green bars, the starch clearance is going down with time, as you'd expect, but that's been halted by certain extent by the 1-MCP treatment. And again, look at this graph. What you see with Jazz equals with Tyler was that the homogeneity of the sample is much tighter. So the brown bars are the 1-MCP treated, and the green bars are untreated. So in the green bar here, you have a much more variable content across the sample taken, and this has been tightened up completely by 1-MCP. And again, we pick the fruits, waiting for red colour. We picked the first pick on the 20th of October. We had most of the fruit have a starch, colour content, but starch was dropping. We waited for a week to pick the treated products, fruit, where we managed to increase the starch clearance again by about 10%, but still maintaining good red colour. Now, this was on an orchard that was about to be grubbed, so I have to make the point that this probably wasn't the best maintained orchard, but due to the restrictions on how much you can apply, then we were slightly restricted. But looking at the ethylene concentration, then this is looking at taking the internal ethylene concentration from the fruit. So the green bars here are the untreated for Jazz, and the orange bars are treated. And again, we have seen some reduction in ethylene with the orange bars, but format probably, but it's still having a bigger an effect on the actual fruit quality, which is reassuring. Now, I know everybody wants to know about when is it going to be around. Well, I'm sure Dan's here can fill you in more detail, but talking to AgroFresh yesterday, they said there's a plan to apply for an emergency permit in the UK for this season. EU, in terms of EU registration, there have been some permits granted for a few countries, including Italy and Spain. And I think the earliest you're going to get it in Europe is 2026. But we'll wait and see, as we all know, it takes time. So that is actually the end of my presentation. I'm happy to take any questions at this point.
Thank you, Richard. Yeah, there are no questions in the chat facility at the moment. One from me, just very quick one. Is it if and when this comes to pass, is this something that you would use in addition to MCP in stores, or would it be as a substitute for? Well, good question. I mean, obviously they're doing two different things. I mean, you don't want to overdo it sometimes. But I think for Gala, there's certainly, you know, and Jazz, I think they're fairly good varieties that could respond to both. So there is options there, and I think, you know, we have to. Well, it's also a cost involved in this, isn't it? So, I think it's what's turned out most cost effective to grow. Okay. One other quick question, which we'll take. What are the spray volumes? Do we know what the spray volumes? Yeah. So he says yes. So I think with going back to my slides, I did see it somewhere with 500 and it was 571 litres per hectare. Okay. We've got another question. Yeah. Okay, we've got another question, Richard, but I think we've run out of time. So perhaps you reply to the question in the chat facility, and other people will be able to see your response to that as well. Richard, thanks for your time, very helpful. And I'm hoping that we've got Feli Fernandez on the line available to present next. We now have two talks coming up on rootstocks. Here she is. Good morning, Feli. We have Feli, first of all, who's going to tell us a bit about M200, and then we'll have Amanda Karlstrom telling us a little bit more about a specific project on breeding rootstocks. Feli, this goes back a long way, this M200, or at least the cross was made a long time ago.
Well, it's older than me, and nowadays that's saying something.
But I think this is
my screen?
But yeah, we can see everything well. I think it's very relevant to today's tree fruit industry. So please tell us a little bit more.
So, thanks for the intro, Scott. I'm gonna take the talk in two halves. I'm gonna go and have a very quick go through what the rootstock program has been at Ismalin, and then I'm gonna focus on M200. And for that last part, I'm gonna be sharing some slides from our industry partners that are currently, that have done a lot of the trialing and the commercializing of the variety. So I'll get to that in a sec. So I love starting with that slide. That's because it picks up a bit of a book that sits in my office, which is the very first lab book of the research station, dated back to 1913. And it basically says when they first thought of having a research station, the first thing they thought it ought to focus was on rootstocks. And I've been obviously delighted to run that program for a number of years myself. The work started with the actual characterization of things that were already out in the industry in the early 20th century, which is one of the reasons why M9 is not really ours and it was never protected, because it was already existing out there in the French industry. We just characterize it, we separate it from other things. And obviously I say we, this is before my mother was born. But anyway, so that material was, released back to the industry, cleaned up and properly characterized. And then straight after that, breeding started. That led to the release of things like N25, 26, and 27. And those were to complement the breeding that was already going on a Merton, so the Molly-Merton collaboration, the MM series, which was developed specifically with the focus of producing woolly apophyllite resistant rootstocks for where then the colonies. More recently, the industry support in the form of the Apple and Pear Breeding Club developed M116 and EM8, which were released in 2001 when I started at Smalling, and M200 that was released last year. The industry investment then continued in the form of the Smalling Rootstock Club that ran from 2008 to 2020, and that program and the industry support for it has been on pause since 2020. So the way the Rootstock Club worked from 2008 to 2020 is we had commercial partnership with funding with INN, which is International New Varieties Network, and the AHDB when it still had a UK grower levy board. INN has continued to run trials of this material, mostly through IFO, which is the sort of trial and testing company in France. It was set up to continue the evaluation of a pipeline that was already pre-existing, and M200 was part of that pipeline. But to tighten up the objectives, Amanda worked with me on this project with a number of years, as did a number of other members of the staff at Smalling. The main program was Apple, but there was a 35% of the program that was dedicated to Pyros rootstock repair. So before this, all the releases of the and all the focus of the program had been on using Queen's rootstocks for pear, but there was an effort to move to doing pear. And then from 2015, we also dedicated quite a bit of effort to develop allied research, including 3 PhD projects, 2 of which have been completed and 1 who is about to be submitted. I'm not going to take you through all of this. This is just to show how very long it takes to breed a rootstock and how very necessary all the things that Amanda's going to tell you in the next presentation are, because this really can go for as long as you can bear it to go. Especially the bulking up and the multi-site trials. It all depends when are you sure that something is good enough. And I'm going to give you some examples using M200 in a minute of just how many trials that can take. But, basically you crosses, you have seedlings, you trial them to begin with in 1 scion, or back when M200 was selected, you looked at the root system to try and predict the dwarfing level. Now we would use molecular markers for that. Then they are evaluated in the field for a number of years. You go to a multiplication test and pest and disease resistance testing. Again, some of that now can be done with markers. Preliminary trial, and this is where then it becomes as long as you want to do it, basically. You have to be confident, and that is more up to the industry than up to the breeders. So there is a bit of overlap in this middle section, and then the industry partners really need to take over and make sure that IP is sort of and is protected, but also that there is enough data for people to be able to get behind a new rootstock. Because if you think it's difficult to introduce a new variety, that is so much harder when it is a rootstock, and you can just show a pretty picture or get somebody to eat a nice chunk of an apple. So the things that we were breeding for was and that would still be true of most programs worldwide, would be a bigger range between M9 and NM106, to give you an idea, with better productivity. Farb light, woolly apple aphid, Phytophthora, Karlstrom, and plant disease resistance. Good nursery performance, which is a problem, especially for some rootstocks like M116, but also some of the rootstocks from other programs. And with pears was the move to queens. Again, a dwarfing to semi-dwarfing vigor between A and C. Resistant to fire blight and good nursery performance, which is very important in pears because they're hard to propagate. And then we continue characterizing persistent material, and that included M200, who was around for all the time that this project ran. What came out of the well, 12 years of funding for the Ismalian Rootstock Club. We've got 1 apple and 3 pear dwarfing rootstock selections that are still in trial with partners. There is ongoing molecular and phenotyping tool development, although that has been paused now. A pre-breeding pipeline, including breeding populations that have been used for PhD work and mapping. And then a breeding pipeline, some of which is still in the field. Some selections that are still in preliminary trials, and some that are just being continued to be removed due to disease or pest susceptibility, as we've been able to test them. So moving on to M200, when I say it's been around longer than me, this is what I mean. The cross was done in 1971 by Ray Watkins. It's a cross between Malus robusta 5, which is a source, is a crabapple type, a source of pest and disease resistance, and Ottawa 3, which is a derivative of M9 developed in Canada for hardiness. It was first characterized as smalling in the 70s and 80s in trials of bigger range between N27 and N26 by Tony Webster and then Ken Tobot's team. In the 90s and early 2000s, the distribution of material through the apple and through what was then the Apple and Pear Breeding Club. It was distributed to a number of partners worldwide. It went as far as New Zealand and the United States, so some of that is now having to be reintroduced with better material to start with, issues with virus indexes and the like. We established rootstock belts, there was propagation trial, initial testing, and then from 2010 onwards, there was enough data to suggest that it might be worth releasing. And therefore, we have spent the last 13, 14 years doing additional trialing to support that, comparing with more modern rootstocks, but also with modern clones of multiple cultivars. We've verified the pest and disease resistance to make sure that that is still stands to modern biotypes and isolates of disease. More recent testing than in these last 15 years includes trials, 2 trial sites in France, 1 in Germany, 1 in Italy, and it has also been included on the ongoing UFRIN rootstock trials. UFRIN is the European Fruit Research Institutes network, and that covers a trial that is running in 12 countries with 16 sites. The highlights of N200 after all of the trial and testing is that it's on average about 30 to 35% more productive than N9 or some clones of N9, and about 20% more vigorous. It's easy to propagate, it gives you a seamless graft union and a very well anchored tree, and it has better disease resistance than M9, including better performance in replant soils. So these are the sites currently running in Europe outside the UFIN trial that, like I said, is all over the place. Now I move on to show you some slides that have been produced by IFO and Dalival, and that's because this commercial trial and this next slide is not my data. I don't want to take credit, but also because there is an economic analysis in some of them, and I want to make it very clear that that is Dalival's data. All of these slides and a lot more of them are part of an online webinar that Dalival produced as part of the release of the variety information. And you know, if you just go online and Google Dalival M200 webinar, you can get the full thing in there, including a very mortifying little clip of myself talking about the material if today wasn't enough for you. So in terms of bigger range, I'm just going to show you a couple of the trials. So in Lamberg in Italy, and the ones at IF4 with Gala and Golden Rangers, you can see compared to Pageant 2 and T337, but also in Lamberg with G11, that it is about 30%, 35% more vigorous, and that is replicated in the other two trials, although less pronounced. So in Lamborghini, the difference with G11 is less pronounced. It is still, you know, significantly bigger than EMLA. And the same with Galaval at Heidelberg, you have an increase bigger measure as trunk, but also if you look at the overall tree size, that also bears true. Sorry, I'm having a bit of trouble moving on. And then looking at cumulative yield, it is, and this is the key thing for why the variety has, or why the rootstock has been released, it is more productive than S9, significantly so. And in a lot of trials, it's also about 10 to 15% more productive than G11. We are seeing a similar distribution in fruit sizes throughout those years, but also we're seeing a little bit more precocity. So it's coming into crop a little bit earlier, although that's not very significant. It is just slightly more productive throughout. The other two trials I was discussing before, one with Dalinet and the other one with Galaval. In most cases, M200 has a significant more production than M9. That obviously changes quite a lot depending on variety, depending on the site. The more important things to remember is that it's more productive per tree. And often that is also the same or very similar to Geneva 11. The economic results, I've got some caveats here. This calculation has been done for the trial, so not on a full-scale commercial orchard. And the test involves 6 replicates of randomized trees for each one of the rootstocks and at similar planting density, but obviously, and they take into consideration the caliber of the fruit harvested, which obviously for European purposes where bigger fruit is favored is more significant. And these charts represent the cumulative turnover so the income in 10 years of planting. And they compare it to a 3-year additional crop for this particular trial, which is with Golden, planted in 2012. And they reckon, this is again Dalival's data, that would produce a 37% increase in income, which would be the equivalent of an extra, as if the M9 had run for another extra 3 years. Look at Gala Brookfield in trial planted in 2015. This is even more stark. So you have a 2 to 3 year bonus cap, but in that case, the turnover, so that the income difference is even more significant. Now, that doesn't necessarily hold true for every trial, but it's certainly very impressive and very encouraging, which is why Dalival has gone for it. Just to summarize, in terms of pest and disease resistance, None of the rootstocks of this bigger range, so M9, G11 or 200 are woolly apple aphid resistant. They're all susceptible. But M200 has better barb blight tolerance than M9. It's not fully resistant like E11, but has much better tolerance. It's also more tolerant to Phytophthora and to replant disease. And it produces significantly less suckers and burnouts. And I was talking before about this very neat graft union, which I'm only keen to point out because it gives you a very, very stable tree, even on sort of say hard wind conditions. And these pictures are actually from the planting at East Mooring as part of the Ufrin trial. This one is from the Gallop Brookfield Bayern trial. And so just to completely drive it home, we're looking at more productive rootstock than M9 on a similar fruit rate, similar range of fruit size, if anything, very slightly fewer on the 70 plus caliber, and a bigger range that is between 20 and 30% depending on the size. This includes replant trials. At the moment, the commercializing is all done through Dalival, so there is no selling directly from UK nurseries yet. But I know Morling Fruits, the Morling Fruits team is working with HDB that would have inherited those rights to the variety to make sure that there's also UK propagation going on. And with that, I'm sorry I've gone very slightly over. Thank you very much for your time. And if you've got any questions, I can answer them on the chat or I can have them at the end.
Thank you so much, Feli. Yeah, I think I'm not seeing any new questions coming in. So if anybody does have any further questions, I suppose a very, very quick one from me is where we got to with the use of this rootstock, and if propagators or growers want to use it, how do they go about doing so?
So at the moment, the easier thing to do would be to get in contact with Dalival in France and order their trees from them because they are the only ones propagating in them number. There is now probably, you will have to, at the moment they are being sold to order as I understand it. So you have to put in your order this year for next year. They don't have a massive stock because they are grafting it on request, depending on the varieties people are interested in looking at. But yeah, so far so good. It's becoming popular. Dalival getting behind it. And so, yeah, I know there's a few UK growers that have ordered some as well, so.
Thank you so much, Feli. There are some more questions coming through to you on the chat facility, so please do reply to them there. Thank you for your time this morning. And that takes us nicely onto Amanda Karlstrom, the second of our speakers on rootstocks this morning. Amanda takes charge of all the rootstock breeding now at NIAB's East Malling site, as well as cherry breeding. And Amanda's going to share with us some information about another growing Kent Medway project, which is designed to speed up the process of apple breeding. So, Amanda,
yes,
the floor
hi.
is yours.
Can you hear me?
We can hear you. I can't see you at the moment. Have you? I did see you shortly. I don't know whether other people can.
My video's on.
I've got you back now. That's fine. Perfect.
Yeah, so thank you to Feli for really giving a good introduction to why we need to speed up the process of apple breeding. And I'm going to focus on scion breeding in this presentation, even though I have been working with Feli on the rootstock breeding as well. And first, I'm just going to introduce myself because I know a lot of you won't know me. So I have worked for 8 years with apple breeding in East Malling, and this has involved both practical breeding, so on apple science, but also on research topics that are all aimed to aid and improve crop breeding. And this has been in apple, but also in strawberry and cherry and apple and pear rootstocks. And a lot of it is genetics, trying to understand how we can optimize the traits in the breeding process by utilizing genetics. And first, I just wanted to explain how conventional breeding works, because I often get the question, it's like, how do you do the breeding is it in a lab. But what we actually do is that we take pollen from one parent. So we decide on a cultivar that we want to use as one parent. We use the pollen to pollinate another tree, flowers on another tree, which we want to have as a mother parent. We then collect the fruit from that cross and extract the seeds, and then we sow the seeds. So it's a very it's very field-based and not a lab-based process. And when you then have those seeds, each seed represents a completely unique individual. And what you want to do with those individuals, if you to develop a new cultivar, is to evaluate which one of them that would be good enough to potentially become a cultivar at some point. And this figure shows that process, which goes through usually some type of a pre-selection. So you sow the seeds out, you get little plants, make some pre-selection, graft the trees on rootstocks, plant those trees as where you would have one tree for each of these unique individuals for each seed. And then you do some phenotypic selections. You select based on maybe fruit quality, which is the best quality. And then the best from this lot of seeds, you would take them, make more trees of them, plant them out, evaluate them again, and then go on to further evaluating the best individuals in large-scale trials, and then moving closer and closer to commercialization and something that in the end becomes a variety. But as you can see, this is quite a long process. So just getting into that where you have some multiple trees from each of these individual seeds can take 10 to 15 years. So apple breeding is a very slow process. And this is a problem when you want to use, as a parent, if you want to use something like the apple in this picture, which has really small fruit and a really astringent fruit. And quite often we do want to use things like this as a parent, because a lot of the pest and disease resistance is found in wild apple relatives, or different hybrids of wild relatives, which a lot of them have this kind of crab apples. And one example of when a crab apple has been used to introduce an important trait is the introduction of a scab resistance gene called BF or RV6. And this was introduced from a wild apple relative, and the first crosses were done in 1914. And it wasn't until approximately 80 years later when the first cultivars that had this resistance were with a good fruit quality that they were released. And the reason for that is because you have to go through several of these cycles, about 7 generations before you get away from these small little apples back to a good fruit quality. So apple breeding is really slow, but the challenges that come to producing apples are not necessarily slow. And sometimes things happen that means as a breeder you need to act or be able to respond quite quickly. And some of those changes can be loss of plant protection products because of legislation, new emerging pests and diseases from other regions, changing climate, so a change in, for example, the amount of chilling hours that you're getting in a region, severely affects what type of cultivars that you can grow and should breed for. So in order to respond to some of these, to the problem with having a really slow breeding process, we started a project together with Worldwide Fruit aimed at facilitating and speeding up the breeding of more resilient cultivars. And this project started in July last year. So what I'm going to do is just go through the different approaches that we're taking in order to kind of speed up the achieving the final goal of having some more resilient cultivars. And we're using these three approaches, and I will go through them in the presentation. And we are focusing on 3 breeding challenges, and they are the 3 major diseases of apple in the UK. So apple scab, powdery mildew, and European canker. And I've put European canker here in bold because compared to the other 2 diseases, there are less tools for breeders to improve resistance to this disease. So this has so canker has been a focus in this project. So if we go through the first approach that we're taking, which is speed breeding, and we are deploying this because we want to enable a quick introduction of new traits into breeding germplasm by speeding up conventional breeding processes. So this is all trying to improve the conventional breeding. And the reasons for doing this is, as I said previously, that it takes several generations to introduce a new trait. So if you want to go get something from a crab apple, it would take decades before you have a commercial cultivar. And the 2 limiting stages that we are focusing on is seed dormancy and the juvenile phase. And seed dormancy is essentially that the seeds, when you collect them from an apple fruit, they are not able to immediately germinate, but they need about 2.5 months in a cold and moist environment before they produce this little seedling. So we want to shorten that period, and then we have an even more limiting stage which is the juvenile phase, and the limiting factor here is that this little seedling, it can grow into quite a decent sized tree within 1-2 years, but trees aren't able to flower the first few years. So because they have a juvenile phase where they are immature, so they don't normally start flowering until maybe 4 to 8 years after germinating. And we of course want to have those flowers because we want to make more crosses with these with the plants coming from these seeds, so that we can get closer to a commercial cultivar. So we also want to reduce this period here from to a shorter time frame. And the approaches we're taking in this project is for early flowering, we are manipulating growth conditions of seedlings, of apple seedlings. So changing the light hours, the enhancing CO2 levels, and growing trees at a high temperature in order to trigger them to flower earlier. And then when it comes to seed dormancy, we are using plant hormones and chemical treatments to shorten the period of dormancy. And the second approach we're taking is developing new methods to select for resistance to European canker. And this is all based around developing molecular tools, so genetic marker tools that can be used to select for more resistant cultivars. And they're all based on approach which uses lots of different genetic markers across the genome. And we are testing if these predictions, so we can use all these genetic markers from the genome to predict how resistant a little seedling would be. And now we're testing how accurate those predictions are in how resistant they truly are. And we're also developing tools to facilitate the introduction of canker resistance from Robusta 5. So this is a crab apple that has a good level of tolerance to canker, and it's also resistant to powdery mildew and fire blight. It's the parent of several Geneva rootstocks and a parent of M200. It has terrible small little fruit, but in order to kind of speed up the introduction of canker from this hybrid, we want to develop molecular markers that can be used in the breeding, so that we can make selections when the little seedlings are only a few months old, and then focus on the ones that have these higher tolerance. And then the last approach that we're taking is developing pre-breeding lines with resistance to multiple diseases. Because at the moment, what we normally have is that you would have one parent that is resistant to one disease, another parent is resistant to another disease. But when to combine them all together, we really need to develop multiple parents that have a good level of resistance to all three of these diseases. So we are using genetic markers to kind of stack all of these resistances into breeding lines, and then they will be so that they can be used as parents in further breeding. So in summary, new apple cultivars need to be more resilient to cope with the changes in disease pressure, and apple breeding and all type of breeding needs to be able to respond faster to new challenges in production. So what we're trying to do is develop methods to breed new tolerant cultivars more effectively, and these approaches can also be used in other tree crops and non-tree crops as well. And that was all I had. If you have any questions.
Thank you very much, Amanda. We are running late, I'm afraid, but thank you for such a succinct and very helpful summary of all the work you're doing. And again, thank you to Growing Kent Medway for the money that they're putting into this project, and also from UKRI. We will move on. Please do keep looking at the chat facility, and perhaps, Amanda, you can just keep your eye on the chat. So if there are any questions for you, you're able to reply. But we'll move on, and just a very, very short presentation now from Laurent Giguere. Laurent is part of the University of Cambridge, and he's been working on a project on looking at climate resilience in the UK apple sector. So Laurent, tell us a little bit what you're doing and what you need our help with. We've got Laurent's presentation. I did spot Laurent. Laurent, if you can unmute and switch your camera back on if it's not on.
Yes.
We've got you again.
So can you see my presentation?
We can hear you and see. I can't see you, but we can hear you. So that's good enough.
Okay, perfect.
Oh, there you go. Thank you.
Hi, everyone. So I'm Laurent Giguere, as Scott mentioned. I'm a PhD student who works on the topic of climate resilience in the apple sector. I'm normally based in Zurich in Switzerland, but since my PhD advisor has moved to the University of Cambridge during my PhD studies, I'm here now to visit, and I decided to use the opportunity to survey some apple growers and work a little bit on the same topic, so climate resilience, but in the UK apple sector. So the goal of today's presentation, it's going to be a very quick presentation. I only have 2 or 3 slides. The goal is just to give you an overview of what my survey is about and try to convince you, of course, to take part in my survey, because that would be very helpful for my research. But I also think that the results that could come out of this survey could be of interest to the UK apple sector. So basically, the goal of the survey I'm doing is pretty simple. It's to do a kind of diagnosis of how apple producers in the UK currently cope with climate change. So to assess their level of resilience to climate change, let's say. The way I do this is very straightforward. In the first part of the survey, I focus on the current impacts of climate change on production. So the direct impacts that are felt through changes in temperature patterns, changes in precipitation, so heat waves in the summer, drought, a bit less chill in the winter also, so things like that. And then there's also, of course, the indirect effects, so all things that are related to pests and diseases, and how this is, of course, affected also by changes in climate. I also, of course, ask questions about which aspects of production are most strongly affected. So whether they're fruit yields, fruit quality, issues related to biannual bearing, so alternate bearing in the orchard, and of course, how different varieties are maybe affected differently. So some varieties are more sensitive to some climate stress factors. And in the second part of the survey, I focus more on the adaptation side. So I'm trying to assess, okay, how much have producers been able to adapt so far, using irrigation, for example, and different technologies, and what is still missing in order for them to adapt to the potential future consequences. And I also have a look, of course, at not just the technical side of things, but also the influence of supply chain characteristics. So whether people who, for example, do direct selling at the farm, or who use alternative sales channels other than selling at big wholesalers or retailers, manage to have more flexibility when it comes to choosing the varieties they want to grow, and if this ends up impacting also their resilience, having specific varieties in the orchard, or having because they have a higher level of cultivar diversity in the orchard. So this is what I'm looking at in this survey. So I hope that I managed to summarize well what the survey is about. It's not too long. It takes about 45 minutes. It's mostly multiple choice, so you don't need to write open answers and to write a lot of text. So it's very user-friendly, I would say. It's an online questionnaire. So you'll see the link and the QR code on the next slide. So it's so if you're interested in participating, you just need to click, scan the QR code or click on the link, and this will take you to the survey. And by participating, you also stand the chance of winning a voucher worth £100 at Sainsbury's. So as a way to thank you for your participation. And if you have some questions, of course, here's my email address. That is tied to my university in Switzerland. So feel free to write me to ask me questions. I will be very pleased to answer. So this was it. Thank you very much. Thanks to all of you.
Thank you, Laurent. And I think what we'll probably try and do is circulate that QR code as well later on for you, just to try and encourage people to take the time to help out. We have run slightly over, I'm afraid, but thank you to all our speakers for this morning. Let's have a